Thanks for joining part 4 of this PICO-8 game development series. Last time we worked on getting collision detection working in our game, so now we have a little pumpkin that can stand on platforms. Today I think what I want to do is clean up the code a bit, and then let's work on the visual side of things a little bit. So I think animation, drawing some pretty sprites, maybe putting in some sounds there so it looks like a platformer. So let's boot up where we got to last time. Let's start by cleaning up our code. So let's start here. This is all collision or hit detection helper functions. We don't really need lines overlapping except to make Rex overlapping work. So I think let's just copy the code in here and paste it in here. So let me just do it like this. Left, right, and this saves us tokens and might even be just a little bit cleaner. And then instead of left it will be top for the vertical, and instead of right it will be bottom. Bottom. Copy that into there and get rid of this. So now we just have a function for whether or not two rectangles are overlapping and whether or not two objects are overlapping. So here's something that we're going to run into. We have a pumpkin, we have coins, we have blocks. Presumably we could add enemies, and then we could add bullets and piranha plants and a bunch of stuff. And if every time we create a new type of object we have to be like local bullets, local piranha plants. Don't know how to spell that word yet. Still learning. Local ramps. I don't know. If we create a new list and have to go through that list and update it and draw it for every single thing we create, this is going to get really long and really tedious. So I think what I want to do is let's create one entity that has all of our game objects in it. And let's call it game objects. So this is going to be refactoring our code quite a bit. We won't have coins, blocks, or let's keep our pumpkin. No, we can get rid of it. So we're just going to have an array of game objects. And then what we're going to do is we're going to iterate through, a list of game objects. Array and list mean the same thing. And what we're going to do is we're going to iterate through the list of game objects. We're going to update them all. We're going to draw them all. And that will allow us just to not have quite so much code. So let's start in this update function. And this is kind of where we can see the gains we'll get. Instead of doing all this, we will just need to do local obj for obj in all game objects do and obj update. And this handles most of what we have here except for this code relating to collision detection, which we'll still need to figure out a generic way to handle it if we just have one array of game objects. And then in the draw method, this becomes super easy. Local obj for obj in all game objects do obj draw. Draw all the game objects. And if you're wondering, this is pretty standard practice to have a concept of a game object that you can kind of throw around and everything counts as a game object. So I noticed that now if I look at when I'm making a block, it has an X, a Y, width, and a height. If I'm looking at my coin, it has an X, Y, width, height, and an update draw. And if I look at my pumpkin, it has an X, Y, width, height, and an update and a draw method. So not only do these all have updated draw methods, they also have a lot of parameters that in common. So let's do this. Let's make a function make game object, and we'll use that to kind of create a base game object that our coin and our block and our pumpkin can all work off of. And the common parameters for all of our game objects are X, Y, width, height. And let's just have this for right now return a new object that has x equals x, y equals y, width equals width, height equals height. Excuse me. X, y, width, height. And then like here in this make coin function, let's start the coin equals make game object, x, y. What's the width and the height of a coin? It's 6 and 7. And then we can kind of add parameters onto it. Is collect equals false, coin.update equals this update function. Its update function is just blank. Coin.draw equals, and then we have the draw function. And then we return the coin at the end of this. I like this better because the coin function is a lot smaller. I dislike it because having it say coin.blah takes more typing on my part. What I'd love to do is I'd love to kind of do it like this. I'd love to just pass in another object, and it is the object of all the parameters that get added to the coin object. And then we don't even need a reference to it, we can just return the new game object. Which means in our make game object function, I want another argument. Let's just call it props. Properties. How do we get all those extra properties onto this object? Local obj equals this object. And then we've looped through every item in a list before. We've looped from like 1 to 14. So we know those two types of loops. There's another type of loop where we can do for, let's look at the PICO-8 documentation. PICO-8 API. Tables. Pairs, used in for k, v in pairs p loops. Great. So there's another type of loop that loops through all of the keys and values of an object. If we were to iterate over obj, the first thing we would get is k would equal to x, and v is equal to whatever the value is set to. Let's say it's 50, and then the code within this loop would execute again, and it would be k equals y, and v equals whatever the y value is equal to. So this is another type of loop. Let's declare our local variables. And we're actually going to iterate through these props. So I have this make game object function. It's being called in the make coin function. I'm passing in extra properties with parentheses. Is collected, update, and draw, and I want to put them on the object. That's as simple as obj of key equals value. Let's change these so that they're key, value. So now we're going to iterate through the props that are passed in. The first thing it'll find is collected, and key will be set to is collected, the text string value. Value will be set to false. And what we'll do is we'll set this object's is collected property to false. So this code just puts all of the properties that are on the props object onto the game object. Add additional properties. And then we want to return the game object. Return option. Lovely, lovely. So now this is a much easier syntax for me to define what it means to make a coin. Let's do the same thing with block. Let's do make game object xy8 2. And you might say that we're not really getting much out of this yet. Like we were just saying x equals x, y equals y, width equals 8, height equals 8. We're not really getting too much of a gain from this make game object function. But we will get more of a gain in the future, and the way we'll do that is we'll add functions and properties onto this generic game object that now every entity will have. So like if I wanted to get the center point, center equals function, return x plus, will be self, return self.x plus self.width over 2, self.y plus self.height over 2. So this function will return two values, the x and y center points of the game object. And just by defining this function here, it is now on every single game object that is created using this function. So we can kind of create a repertoire of functions, useful functions that will be on every game object to make coding easier. One thing I want to do, let's do this. Let's say update equals function self end. Do nothing. So what we've just done is any game object created with this make game object function will come out of the box with a blank update function, which means if our coin doesn't need to do anything to update, we don't even need to define it. And same thing with our block. But if we do want our coin to like do something, we just define it here, and then it will overwrite the blank update that's defined in this object. Oh, one other thing we can do is before, whenever we made a coin, make a coin, we would need to add it to the list of coins. And whenever we made a block, we would need to make sure to add it to the list of blocks. Let's just have it that whenever we call the make game object function, add it to the list of game objects. So we'll do add game objects up. So it gets automatically added to the list. We don't need to have this add syntax everywhere. Add. Do. Shoot. There we go. Make block. And we don't need these anymore. I want to, let's make a function that's make pumpkin. So that this isn't, all this code isn't right here. And all of our code related to making entities is in one place. Let's just have pumpkin equals, oh wait, we don't even have a pumpkin variable anymore. Let's just do make pumpkin. Where was the pumpkin? How big was it? 64, 24, 88. 64, 24, 88. Let's define that make pumpkin. Function make pumpkin. XY. Oh, right. When we make a pumpkin, it knows its width and height, so we don't need to pass those in. We just need to pass in the x and y values. Return make game object xy width or 8, 8. And then our pumpkin has a bunch of additional properties, including velocity. It will define an update function. This draw function is massive. There we go. And it will define a bunch of other properties. We need to close that. This is all of our game object creation functions. It's always good programming practice in pretty much everything you're working in if the top level of your code is all like really simple and easy to read. So now in our underscore init function, it's really easy to read. We're just like making pumpkins, making coins, making blocks, and not doing anything else. Oh, we do need to initialize the game objects to an array, to a list. Let's add some comments. Draw all the game objects. Draw the score. Update all the game objects. Now, so it still works, no errors, except our pumpkin is just falling straight through stuff. So we've broken it, but we knew that would happen. So we need to figure out what's a good way to do this collision checking code. We have two forms of collision detection. We have when the pumpkin is overlapping a coin. That is just checking to see if the bounding blocks are overlapping. When the pumpkin is colliding with a block, that is, we have 4 different little hitboxes that are checking for that. So I think let's have it be such that every game object has a method that checks to see if it is a hitting another object, which means that their bounding boxes are overlapping, and another mechanism to check to see if it's colliding with another object, which will be the more advanced way of detecting. I think we'll have enemies and stuff that will also be colliding with the terrain, so I think every game object should have these functions to start. And then maybe some of them won't use them. Like a coin probably won't need to check for collisions. Let's add a default draw function. Don't draw anything. And let's start to add check for hit self with some other object. And let's say check for collision self and some other object. Let's do the hit one first. If bounding boxes overlapping self other, then they are hitting each other. So I just want check for hit to return true or false, and then objects can use that to determine if they're hitting another object. So this might be, for now, just really simple. We're just going to return this call. But it'll get more complicated in the future, which is why we want to put it in its own method now. Let's re-implement the coin hitting now, just to see what that looks like. So before we had the collision checks up here. I think I want to have the pumpkin be responsible for doing its own collision checking. So check to see if colliding with a coin. And the way we'll do that is local obj for obj in all game objects do if self, because this pumpkin now has a check. For hit function, if it's hitting the other object, then, oh wait, we're already doing check for coin collision. Let's just get rid of this. Sorry, we don't need to expose that method publicly anymore because we're calling it within the function, within the class itself. Let me just copy what happens. If check for hit object and not the object represents a coin and not is collected, then obj dot is collected equals true, score plus equals 1. The problem with this is we are checking against all game objects, not just coins. So we need a way of just checking to see if the pumpkin is colliding with a coin. One thing we can do is we could add a little like object name or entity type or ID to our game objects that we can use to compare, like to see if a coin is a coin. So let's do this. Let's have the first property passed into the make game object to be the name of the type of object. Name equals name. And we'll set that on the game object. So for example, if we're making a coin, we'll just have coin. If we're making a block, we'll just have block. And if we're making a pumpkin, we'll pass in pumpkin. So now every entity type has its own name. Coins have a name of coin, blocks have a name of block, pumpkin has the name of pumpkin. We could use any variable name, it doesn't need to be a name, but I'll just use that for now. And now in our pumpkin's update code, for every object in the list of game objects, we're going to check for a hit, but we're first going to check to see if obj.name equals coin and the other stuff. And now we're only looking at coins. So I should be able to collide with coins now. I still fall through blocks though, so that ain't no good. So the next thing we want to do is check to see if colliding with blocks. If hitting blocks, rather. And the way we'll do that is much the same. For obj in all game objects, do if obj.name equals block, then and check self check for collision obj. Then, what do we want to do in that case? Well, we want to handle the collision. So maybe check for hit determines whether or not the objects are overlapping, and it just returns true or false. Check for collision, let's make that return if they are colliding, returns the direction that they are colliding from, either top, left, bottom, or right. And we have all this code here related to checking for collision. I'm going to copy that. And we're going to move that into the check for collision method. So this all makes this stays the same, but if the bottom hitbox is colliding, is overlapping the other object, then I just want to return, let's say down. If the left hitbox is overlapping, we'll return left. Return the other ones. Otherwise, it just won't return anything, which will end up being the same as saying return nil. But we don't need to write that. It returns nil by default. All functions return nil if you don't specify what they return. So now we have a magical little function on every game object that checks to see if the first object is colliding with the second, and if so, it will return down, left, right, or up. And we're calling this check for collision code with a block. Let's paste this here, which will be how we handle it. Local. So what we'll do is local collision dir equals check for collision. If collision dir does not equals nil, so if we do have a collision, what we'll do is basically the same stuff we had here. Except we'll just say if collision dir equals, what was it? Bop equals down. And then this is if collision dir is left. This is right. And this is up. So we have a fancy little method that determines if one game object is colliding with another object, and if they are, which direction they're colliding from. And then we already know what to do if they are colliding. So let's run that. It was very sad. Oh, we're referring to block here, but within this loop, we're actually talking about obj. So we need to update that. Obj. Oh, maybe this was referring to the wrong thing. Other. Block. This is also referring to the wrong thing. Other. There we go. And now we've restored peace in the galaxy. We can again hop on little blocks. How can we make this even better? So I think most entities will want to handle collisions in the same exact way, basically the same way, where you'll want to move, if they're colliding, you'll want to move them out of it. Some objects, like let's say we had a rocket and it hit a wall, maybe it just blows up, so it doesn't need to move out of the wall first. But most objects that are checking for collisions will need to handle collisions the exact same way. So let's say this. Let's look at our coin. Let's say that function self, let's add an update function to our coins where the coin just moves down, self.y. So our coins fall through the floor. Let's get it so that they don't fall through the floor in the minimum number of steps, just as an exercise. Block. So we were going to loop through all the game objects. If they're blocks, then we're going to check for a collision. And if there is a collision, let's say that there's a function handle collision. That handles, we give it the object and the collider. So now our entity needs a handle collision function. And the reason we're moving them into separate functions is because, like I was saying before, not everything will handle collisions in the same way, but most objects will handle collisions in this way. And all it's going to be, is basically what we had up here. Handle collision. Other. Standing on block, we don't need that. So handle collision, check for a collision checks to see if two game objects are overlapping, and if so, in which direction. Handle collision moves the entities so they're no longer colliding. So now, in our coin, we can just say this handle collision thing. And now, whoa. So our coins don't have a concept of velocity, which makes sense. We didn't add velocity to it. Velocity is such an important concept that I think it should be on every game object. So let's add it. So it's on every game object and 0 to start, which means we don't need to define it on our pumpkin. So now every game object has a concept of velocity. And we can see before when our coins were moving down, now they hit the floor. And you can see the one on the left does a little funny loopy-loop. I think that's because coin, make coin. So the width of the coin is 6, and the height of the coin is 7, and our collision detection code puts in a 3.1 pixel divot into the object. But because our coin is only 6 pixels wide, putting in a 3.1 pixel divot actually creates a negative area hitbox, which can cause issues. Essentially what we have is on our pumpkin, we have these areas here. And we have this little divot here so that if an object comes in from the top, it will check against the blue area first and know to move the object up, and it won't intersect with the green or yellow area, which might make the object move to the left or right instead. If we were to increase the size of this divot in the side, what would happen is our collision detection would be able to handle the object moving faster, but it would miss out on collisions like if an object was right here. It would not count it as colliding with the object. So there's a little bit of a trade-off between what's the maximum speed the object can go and whether or not it detects collisions from the side like this. Our coin, though, has so much of a divot that these little hitboxes are being turned inside out. That's screwing up the math that we have for checking to see if our rectangles are colliding with one another. So what I'm going to do is let's have this little divot here be parameterized so that maybe the pumpkin is something like this, and then the coin, which is smaller, has something more like this. And the coin won't move as fast. So passing in an offset, we'll just plop that here and subtract twice the offset here. Now, when we're checking for a collision for the pumpkin, we'll pass in 3.1, which is our little offset. Or let's call it indent. The better word. Indent. And then when we're doing that for our coin, which is smaller, let's just pass in 2. And now the coins can properly collide with the ground and not intersect into it or do something weird. Hooray! Mathy stuff! There's a lot more cleanup to be done though. Let's just go through it. Create game objects. Create a pumpkin. Create some coins. Create some blocks. Update. We don't need this anymore. So now our update function is super clean. We just update all the game objects. Great. Our draw function is also very clean. I think this syntax is a little hard for me to read. I keep forgetting which one is width and which one is height. So I think what I'm going to do is put these back on the object like this. Width, height. Width equals 8, height equals 8. Just a little bit too hard for me to read. Width equals 8, height equals 8. And then in the make game object function, it no longer takes a width and a height, and it no longer plops those onto the object. This is a little wordy, I feel like, doing these loops. Let's write a helper function. Function for each game object. And what we're going to do is we're going to pass in the name of the game object we want. And what we want to do, let's call it a callback. For each game object, what do you want to do to it? And the way we'll do that is, we'll go obj, for obj in all game objects, do if obj.name equals name, the name you passed in, then we'll call the callback on that object. So we just made a helper function that iterates through every game object, and for each game object calls this parameter, which is going to be a function. So you can pass functions into functions as an argument, but only if the object name is equal to name. So for example, all game objects, let's see. So here, instead of doing all this, let's just do for each game object coin function coin and yay end. And instead of an object, we now know that we're dealing with a coin. That's the parameter here. So it's a little bit cleaner for each coin. And we can do the same thing here. For each block. And we're no longer talking about an object, we're talking about a block. Wait a minute. Oh, we have all this collision code, but actually we have a helper function that does that now. We can just call self handle collision. Collisioner. Oh, block collisioner. Is that right? Is that the other dir? Great. And the only part we need from this is our handle collision function gets the pumpkin out of the block, but it doesn't do this code. It doesn't say if the collision is down, set this as standing on a block to true. Here I wrote handle collision, even though I haven't checked to see if collision dir is null yet. If you pass in dir equals nil into this function, handle collision won't actually do anything. It won't break, it's fine. So we can just call handle collision without first checking to see if collision dir is non-nil, if it's defined. So for each block, check to see if there's a collision. If there is, handle the collision. If it's colliding down into an object, set this as standing on the object. Let's move this down here so it's closer to the relevant code. We had this here in the coin function to check to see if it's colliding with anything. Wow. Oh, we have an end here. We don't need it. If check for hit coin. Check for collision. Yes. There we go. Everything's still working. Let's have our coins move to the left. Yeah, and now they pile up there. But I just did that for funsies. I don't think we even want our coins to move at all. They're just going to be static. For each game object helper function. Let's say game object helper functions. So I think that was really good cleanup. It's a lot better now. All of our ugly code is within the make game object function, which if we just hide, we don't need to think about it. And we can just focus on writing the code relevant to each game object instead of writing generic code that every game object should have. Yes. But I think next I want to do is, we've been working with this little pumpkin for a while. I think now's the time to say goodbye to it. Let's draw something better than a pumpkin. It's been very dear to us, but we want something that can animate and move. Let's make a little character. Little pants. Maybe some eyes. What I want though is I want a character that can animate. So let's draw. I'm just going to copy and paste that. What would this character look like if they were walking? Well, they would have one frame. Animation is just frames displayed one after the other, quick enough that human minds misperceive it as actual movement. So I'm just going to have a frame where the character's feet are close together, one where they're close apart, and we're going to fool the human brain into thinking that this character's walking by just playing them back and forth real fast. Let's make another one where the character is jumping. We'll have their feet out to the side like that. What a cutie. Maybe they'll be looking up. And then maybe when they're falling, we'll have them look down. Do we need anything else? We want to be able to move, so the character is sort of facing to the right. We want them to be able to face to the left, but we'll be able to do that just by flipping the sprite when we're programming the code. So I think let's just start there. Let's have that be our character. And our pumpkin's draw code, we're still drawing sprite 4, which is this, but we want to draw sprite 8, which is this. Let's draw our bounding rectangle real quick. Self to X. Or how about this? And our make game object code. Let's have draw bounding box be a function. And you can pass in a color, and then it will call self, or it'll call rect self.x, self.y, self.x plus self.width, self.y plus self.height, color. Now, if I ever want to draw the bounding box around an object, all I need to do is call self draw bounding box 7, which will be white. And now every game object has that method. And we want to draw 8, I believe was the sprite. 8 instead of 4. Yes! Beautiful. So the first thing I need to do, pumpkin. It's no longer a pumpkin, it's a player. I want the player character to have a facing. They face left or they face right. Is facing right equals true. Or let's do it like this. Is facing left equals false. This, if button 1 is pressed, it moves the character to the right. If button 0 is pressed, it moves the character to the left. Let's say if you're pressing the right arrow key, then is facing left equals false, because you're facing right. Self that is facing left is false. If you're holding down the left arrow key, then self that is facing left is true, because you are facing left now. So our character will now switch directions depending on which arrow key I press. And all we need to do is, let's look at the PICO-8 API again, graphics. So the arguments you can pass into the sprite function are n, which is the index of the sprite. We're passing in 8, the x and y position you would like to draw the sprite, the width and height of the sprite, and whether or not it should be flipped. So we just want 1, 1, always. We're just going to draw the one sprite. But if we were to pass in true here, the character would be flipped and facing left. And if we were to pass in false, they're facing right. So this parameter determines which way the sprite is flipped. We want to flip it based on whether it's facing left. If it's facing left, we do want to flip it. If it's facing right, we don't. Now if we run our code, if I press left, my character faces left. If I press right, my character faces right. Let's make that more obvious. Let's add another element to our character. Let's add a little nose. Wonderful. Whoops. Put there. just so we have a way of telling, easier way of telling which way the character is facing. But we don't just want to change the facing of our character, we want our character to animate. We want them to walk around. And we have little animations for that. Let's do this. We have these little animations for whether or not the character is... When the character is jumping, we have these two sprites for that, whether the character is jumping up or jumping down. Let's do this. Let's say local sprite num equals 8. And we'll pass in the sprite num here. So we're now passing in 8 still. But if we're not standing on a block, then, or let's just say, if self that is standing on a block, if we are, then sprite num equals 8. If we're not, then sprite num equals 11 or 12, depending on whether the character is moving up or down. Let's say, how do we determine whether or not the character is moving up or down? We just look at the velocity, which is velocity y, which is how fast the character is moving up and down. So if self.velocity y is greater than 0, that means the character is moving down. Velocity y is positive, meaning the y value is incrementing every frame, meaning the character is moving down. And our moving down sprite is 12. So we'll do that. Boop. Else sprite num equals, otherwise the character is moving up in the sky, so the sprite num will be 11. Yay. Let's try that out. Boing. Boom. So if the character is standing on a block, we can do the same thing where let's look at the x velocity, which is how fast the character is moving in the horizontal axis. If self.velocity x, if it's 0, if the character isn't moving at all, then let's display this little standing animation. Else, we want to flip between this and this, 9 and 10. Let's just say sprite num equals 9 for now. And if I move, you can see my character's legs spread out a little bit. There's some silliness. So the way we're halting to a stop is we are applying friction every frame, which is, let's just draw the velocity of the character. Print self.velocity x, so at x at y minus 10, 7. So we're drawing the x velocity above the character. You can see the value goes to 0. When I move to the left, it's negative 0, which I didn't know was a thing. Let's do this. Or self.velocity x equals negative 0? No, it's not a thing. So the negative 0 is a rounding error for printing it out. Maybe. I don't know. I've never seen that before. But let's do it like this. If self.velocity x, let's say if it's almost 0, then we'll draw the standing sprite, which means if velocity x equals negative 0.1, self.velocity x 0.1. So this condition, this mid-function keeps velocity x between negative 0.1 and 0.1. This condition checks to see if I were to clamp the velocity to some very small amount, would it be the same as what it is? Which will only happen if self.velocity x is very small, specifically between negative 0.1 and 1. And that'll be our new condition, is not checking to see if velocity is 0, checking to see if velocity is real small. Which we can see the character now halts properly. Let's get rid of that velocity. But here's the thing, I don't want my character to just slide across the ground, I want them to walk. Let's set our move speed to 1. So the character's still sliding. How do we get it to walk? Well, we need to alternate between 9 and 10. And the way we do that is, how do we alternate? Let's have a walk counter variable set to 0. And what we'll do is we will have that counter go from, let's say, 4 to 0. So if it's at 0, we'll put it back at 4. If it's above 0, we'll just reduce it down to 4 or down to 0. And what we'll do is we'll display 9 or 10 based on where that counter is. If it's above 2, we'll display 9. If it's below 2, we'll display 10 or something like that. Update walk counter if self.walk counter equals 0, then self.walk counter equals 4, else self.walk counter minus equals 1. So now we have a little counter that goes from 4 to 0 and back up to 4. Let's just draw that above the character to verify. Now it's going so fast that I can't even tell, but it seems to be doing something. Else, so we're just drawing sprite 9, but I want to draw either sprite 9 or sprite 10, and we'll do that. Else, if walk counter is less than 2, then we'll draw 9. Else, we'll draw 10. Let's see what that looks like. Whoa. What happened? Self.walk counter. No. Oh, I got rid of the sprite drawing. Whoops. There we go. Okay, great. So now my character is alternating between legs out and legs in. It's a little bit fast. So one thing we can do is we can, let's say if the walk counter is less than 4, and let's have this be 8. So I want the character to have half the frames their legs are out, half the frames their legs are in. So if we start at 8 and go down to 0, halfway between that I believe is 4. Great, now our character has a little walk animation. And we have a little jump animation, and the character properly looks left or right. One last thing for today is let's add some sound effects. Let's add a sound effect for when a coin is collected. Let's add a sound effect for when the character jumps. Let's go to this tab, which is our sound effect tab. I'm going to go over to sprite sound effect 3, which is the first sound effect I have that's blank. And let's do the jumping sound first. So when you jump, typically it is a increasing pitch, and the reason for that is you're going vertically upwards, which we associate with a higher pitch. That's why we call it higher. There's also a concept of when you're going upwards, that's equivalent to like if you had a rubber band, you're stretching it out more, and when you pluck a rubber band and you stretched it out more, it's higher pitch. So jumping is sort of like going into a higher energy state, much like stretching a rubber band is going into a higher energy state. So I'm just going to go into the drawing mode, and I'm just going to do. Doesn't sound quite right. And let's get rid of these last two. So you can hear that there's individual notes. There's 8 individual notes being played here. I don't want it to be notes. I want it to be a smooth effect. There's an effect for that, which is effect 1, which is a slide. It's a smooth transition. So I'm going to put that on everything except for the first. And what this does is, if there's a slide on this note, it means that it will be played sliding from the note above it to the note that it is. So instead of going from stepwise from a G to a C sharp, if the C sharp has a 1 effect on it, it will slide from G to C sharp. Which means if we play it now, it's much more of a smooth slide upward. I want it to be a little faster, which is a lower speed. Let's try the different voices. I like that one. I think I'm going to stick with this one just because it sounds old school gamey. Let's make the blue numbers of the volume. I'm going to make the volume a little lower. And I'm actually going to have it fade out a little bit because the loudest part of the jump should be at the start when you're kicking off the ground, and it should kind of fade out. Great. While we're here, I don't think I want to do anything else with that. That sounds good. While we're here, let's do a coin collect sound. Typically, sound effects when you collect a coin are want to give a sense of reward. So that usually means playing notes that are consonant with one another, usually in the major key. Kind of, the major key is a very happy key. Oops. Let's have this last note fade out a little bit. Let's have it be a little bit faster. Let's try the different voices to see what sounds good. That's nice. I like this. Is there anything we can do to jazz this up a little bit? We could have, let's just try different effects. If we do the slide, it kind of sabotages it a little bit because we don't hear the individual notes. If we do 2, what is 2? Vibrato. Adds a little wiggle to it, which I actually like. I think that sounds good. 3 is drop. That's more of a lasery sound. We don't really need that. Or a drum beat sound. 4 is fade in. That kind of makes it sound a little harpy because each note is fading into the note, so it's starting silent and going louder. Or maybe not a harp, but like a flute or something like that. I don't mind that. Let's see, a 5 is a fade out. So now the notes sound extra punctuated because every note is starting out loud and then fading out. So you can really hear the notes. 6, arpeggio fast. So that will mean that every single note that's played here, it plays all 4 of these notes really fast. But you can kind of hear the wum wum is actually C, E, G, C over and over again really fast. 7 is the same thing but a little bit slower. So what did I like from this? I liked when this faded out a little smoother. I kind of liked the drop. I like these fade outs here because that makes it sound a little more bouncy. Let's see if we can... And I like it a little bit faster. 3 is our jump sound. 4 is our coin collect sound. Let's do that. Is collected. So I want to play my coin collect sound whenever a coin is collected. Coin collect sound is 4. This is where the coin is collected. All I do is sound it. SFX 4. This is the jump sound. It's sound effect 3. Let's find where I jump. It's right here. Jump when Z is pressed. And all I do is I play sound effect 3. So now I have a little sound effect when I collect coins and when I jump. Let's have one more sound effect for when the character lands. I'm going to say if we're having a certain voice for when we're jumping, we should probably have that same voice for when we're landing so they sound like related actions. So let's do this. It might be as simple as that, where when you land, you just hear. How do we tell when we land, though? Here's where, if we're colliding down into a block, we are checking to see if the collision is downward, and if it's so, then we're standing on the block. We could try putting the sound effect here, but you just hear that sound constantly, and that's because I said before, what's actually happening is every single frame our character is falling into the floor slightly and being pushed out of it, which means this code is triggering every frame that our character is standing on a block, which means our sound effect is playing constantly. So how do we get it so that this sound effect only triggers if we go from an airborne position to a standing position. One way we could do that, I think the best way is was standing on a block. A block equals stuff that is standing on a block. And when we land on a block, we only trigger the sound effect if we weren't standing on a block before. And that works because when we're airborne, we're not standing on a block. If we collide with the ground, that means we went from a state where we weren't standing on a block and now we are. So the sound effect can play. If we are standing on a block at the beginning of the frame and then we collide with a block, it means we didn't go from airborne to grounded. We went from grounded to grounded, which means we shouldn't play landing sound effect. Lovely. So I think we made some good progress. We cleaned up our code, and we have a character that moves around and animates. If you have anything you'd like to say, feel free to put them in the comments below, or message me on Twitter, which you'll find in the description. But thanks so much for watching.